In this recording, we're going to have a quick look at a number of examples from the textbook, Year 9 textbook, Chapter 13, Exercise D. It's looking at some of the worded equality statements or questions. Okay, so 13D, question 5. I'm going to work through the examples here, and I'm going to display the question at the top. Bananas cost 12 cents and grapefruits cost 23 cents. Okay, so let's get the information down that you know to start with. Bananas 12, grapefruits 23. Now we've got to look at the number of the different fruits. Now if I buy 3 more bananas than grapefruits, well then I know down here that there are G number of grapefruits. So just pick a letter, it could be N, but I've used G for grapefruits. Then there are bananas, right? There's 3 more bananas than grapefruits. So don't put this number in terms of bananas, put it in terms of the other variable, the first variable, because I know that the number of bananas is however many grapefruits I've got plus 3 more. Okay, so that describes the number of bananas. It doesn't really talk about grapefruits other than equating the two amounts. So our total is $2.81 or 281 cents. We're going to work in cents because these things here are in cents. How do you get the total cost? Well, there's your $2.81, and however many grapefruits I've got, I'm going to multiply by 23, and however many bananas I've got, I'm going to multiply by 12. So our statement here is 23G plus, and I just expand this bracket to get 12G plus 36. Subtract 36 from both sides. There's my number of grapefruits. And bananas, well, there's 3 more bananas than there are grapefruits. Therefore, there are 7 grapefruits and 10 bananas. So there's question 1. I'm going to go straight now to example 6, question A. And this is looking at age. I'm going to scroll down here. Okay, so a man is currently 3 times as old as his son. Let's get this information down. Unlike question 1, where we're trying to get different variables, when it comes to ages, we're going to use different variables and then substitute. This is what we call simultaneous equations because we're going to try and solve these things at the same time. This is how it works. A man is currently 3 times as old as his son. So let's write that information down. And this is the first equation, which is why I've got a 1 in front of it, behind it. In 11 years from now, he, the man, will be twice as old as his son will be then. Now, his son will be plus 11. Okay, here's my plus 11. He has changed by 11. But the man will be twice that age. Notice how we've got M and S in both of these equations. Now, if this is the man here, which is 3S, and then the man is also, and although it's at a different time, our equation says M equals this and M equals this. Now we know that M equals M, right? Because we've chosen the same variable. Just think about it in terms of algebra. M equals M. So if from equation 1 and equation 2, I'm going to equate the right-hand side of these two equations because there's an M and there's an M. So by equating these two things, I get 3S equals that statement. I expand and I get 22. Now the trick with this particular question is that that is the son's age. Now, going back to the question up here, that's the son's age in 11 years' time. So we need to subtract 11 to get back to today, and the answer is 11. Now it's tricky, but let's just look at a couple of other questions and just see if you can identify the pattern. First thing, you've got to write down the information. At present, Guido is 8 years older than Bob. Now just be careful with this. Guido is Bob's age plus 8. The plus 8 goes over here. Okay, the temptation is to say G plus 8 equals B, and it's not correct because at present he is older than Bob. Now, so we need to add 8 to Bob's age to make Bob the same age as Guido. So that's our first statement. If Guido was 1 year younger, okay, so here he is, 1 year younger, he will be double Bob's age. So there is double Bob's age. Now again, we're trying to make the G's match up. So what I'm going to do with this equation is just rewrite it. I'm going to add 1 to both sides, and I get G equals 2B plus 1. There's my first equation, there's my second equation, and we're going to equate, okay, make them equal. G, B plus 8, 2B plus 1, and by moving the values around, I get Bob equals 7. Make sure you answer the question, how old is Bob? Sometimes you might solve it in terms of G instead of B. Just make sure you've answered the question. We'll keep going. Here's question C. In 5 years' time, Pam will be twice as old as Sam was 2 years ago. Okay, in 5 years' time, Pam. So here we are. In 5 years' time, Pam will be twice as old as Sam was. Here's Sam, 2 years ago, twice as old. Okay, so we get this equation here. P plus 5 equals 2S minus 2. Go to the second part of the equation. Pam is 8 years older than Sam. Now it's the same situation as I've described in question B. If Pam is older, then we need to add 8 to Sam to make them equal. Okay, Pam is older, so we need to add 8 to Sam. Now what we've got is 2 equations. This time, if P equals S plus 8, then I can put the S plus 8 in place of the P in this equation, and that's what I'm doing, substituting equation 2 in equation 1. There's my S plus 8, and away we go. This is just algebra now. S, bring the S over there, add 4 to both sides to 17. Sam is 17 years old. Last one. The sum of Peter's and Susan's ages is 20. There's the sum, 20. If Peter's age is doubled, so let's double Peter's age, it will be 5 more years than Susan's age trebled. Okay, so here is her age trebled, and here's 5 more. Okay, if Peter's age is doubled, there's 2P, it will be 5 more than the trebled value. Okay, now in this case, I'm going to go back to equation 1. I'm going to rearrange equation 1 to make P the subject. P equals, so what I've done is I've taken this S and subtracted it to this side. So now that I've got P, I can put P into equation 2. 2 times that equals that, and again I'm just rearranging in terms of algebra using the balance method. So there's a couple of questions for age in particular. You know, what we're aiming to do here is to make sure that you interpret the information correctly. And most importantly, for all of these questions, right, we see that we're getting 2 equations in terms of the 2, or in this case, the people. Okay, M and S, G and B, P and S, P and S again. So we're getting 2 equations, and then we are substituting one into the other, or we are equating. Because I've got a G and a G, because I've got an M and an M, I can equate those 2 things. In these 2 last ones, I use substitution to get rid of one of the variables and make it only have S's in it. You've got to get rid of the second variable, otherwise we can't solve this. So there's a range of questions from the textbook. I hope that helps. And just practice these ones. Go away and do them again and see if you get the idea.